solve few of the circuit examples in order to see that how and where can we use the complex numbers in the real life. So they might give you the complex numbers can be used in order to determine the total impedance and the flow of electric current. Now, impedance actually it is an expression expression of the opposition that an electronic component or the circuit offers offers to the direct current. Okay, there are three basic components of the circuit that are known as the resistor, inductor, or capacitor. Now, resistor actually dissipate the energy, whereas the inductor and capacitor they store the energy. Now, since the resistor dissipate the energy, so it can be shown, or it in a complex world a plus bi, you can say, okay, in a complex number they are the real numbers, they are shown by the real numbers, whereas inductors and capacitor they store the energy. That's why they are represented by the imaginary numbers. Now, in inductor, always remember that inductor will be represented by a positive number, whereas the capacitor must be a negative imaginary number. So memorize. Now remember that this shape in a circuit shows the resistor. The spiral shape shows the inductor and it has to be a positive imaginary number. Capacitor is given by this kind of series and it has to be shown by a negative number, negative imaginary number. Let's try to solve few questions. Look at the, before doing anything or reading anything, I can ask you to look at the diagram. Ohm's law states that the voltage is the product of the current and the impedance. If the current for this circuit is given by 13.2 plus 1.9 I amperes, what is the voltage for each component in the circuit? Now we have to find out the total impedance as well as the voltage of each component. So how to determine first of all, look at this. Okay, this figure over here. This figure shows the resistor, right? And we know that the resistor will be given by a positive real number. Now here they are saying that resistor is 9 ohms. Now 9 ohms should be a positive real number. Now this spiral thing means this is shown, this shows the inductor. Inductor must be given by a positive imaginary number and they are writing 4i. It means it would be taken as 4i ohms. Now capacitor must be a negative imaginary number. So it is already given as, this is the capacitor, this shows the capacitor and it is negative 2i. Now in order to find the total impedance, actually it is the sum of all the components of the circuit. That means resistor plus inductor plus capacitor. So resistor it is equals to 9, inductor it is 4i and capacitor is negative 2i. Add the real number with the real number and there is only one real number, that is 9. Add imaginary number with the imaginary number, plus 4i minus 2i gives us plus 2i. So this is the total impedance of the circuit. Now they are asking you to find the voltage for each component. Now voltage of resistor. Voltage of resistor will be given by the current times the voltage of the resistor, the flow of electrons of the resistor. So you know that the resistor is the flow of charges of the resistor is 9 ohms times the current of the circuit. The current of the circuit is given as 13.2 plus 1.9 I. Now find out the voltage of inductor. Now inductor is given by 4I and multiply by the current, that is 13.2 plus 1.9I. Similarly, voltage of capacitor is given by negative 2I. Multiply the negative 2I by the current, that is 13.2 plus 1.9I. Now you can just write it in the calculator and get the answer, and that would be the voltage of resistor, inductor and capacitor respectively. Now I am pause the video and find out all the answers. You can write it in the calculator directly, okay, by using the mode complex, and then in order to write the I, press E and G, which is just above the 8 cursor. Okay, so the first one will give us 594 over 5 plus 81 over 10I. Okay, and then write the second one. Find the voltage of the inductor by multiplying the 4I by the current, and it will gives us minus 18 over 5 plus 264 over 5I. Similarly, in order to determine the voltage of the capacitor, multiply the negative 2I by the current, and you will get in the end 9 over 5 minus 132 over 5I. That's all. Let's practice another question. Use this diagram. Now we know that 7 omega or 7 ohm, actually it is the resistor because this is the figure of the resistor, and 3 ohm it will be the inductor because the spiral view will be inductor. Now you can see they are not writing any I, but we know that the inductor would be an imaginary number, so write down 3I. Now capacitor, it's 4 omega, okay, 4 ohm, that means, and the capacitor must be a negative number, so it should be a negative 4I. That is a capacitor. So don't forget to understand these things. So first find the total impedance. So in order to find the impedance, we add the resistor, inductor and capacitor's voltage, that is 7 plus 3I and negative 4I. Now real number will stay as it is, whereas the imaginary number 3I minus 4I will gives us minus I. So this is our total impedance. Now find the voltage of resistor, voltage of inductor and voltage of capacitor. So voltage of resistor will be 7 times the current of the circuit, that is 16.8 plus 2.4I. Voltage of inductor will be 3I times the current, that is 16.8 plus 2.4I. And in the end, voltage of the capacitor is negative 4I times 16.8 plus 2.4I. Now write them all together one by one in the calculator to check your answer. So better I would suggest if you write directly in the calculator to check the answer. So the first one will give us Okay, so I forgot here to write the I. So the first one is 588. You also check my calculation, please. 84 over 5I. Then the second one, voltage of inductor, will gives us 3I, that is minus 36 over 5 plus 252 over 5I. And the last one is voltage of capacitor, which should be written by the negative 4I times the current, and it will gives us 48 over 5 minus 336 over 5I. So check the calculations, and it is so easy if we practice, and remember that in the maths always practice makes you perfect. Now look at this diagram. In this diagram, you have to find out the total impedance and the voltage of each component. But what have you seen? That in this diagram, I have a resistor and I have a capacitor. There is no inductor. So don't worry about it, because in some of the series, it might happen that some of the component is not there. So you don't get upset. Just write the total impedance. It is equals to, now in your case, it's equals to the resistor, sum of resistor and capacitor. Resistor is the real number, so write the 2 as it is. Capacitor is an imaginary negative number. Now it's already an imaginary negative number, so just write as it is, and it is your total impedance. Now to find the voltage of capacitor and voltage of resistor. Now if they write voltage of inductor, so you can say that there is no inductor in the series. Inductor in the circuit. Okay, in the circuit. So it's 0, of course. Now voltage of resistor, it will be 2 times your current, that is 24 plus 12I. Similarly, capacitor is negative I times 24 plus 12I. So just write down and multiply it. So you will get 2 times. I would suggest if you will use the calculator and write the I also by using the complex mode. Okay, here you will get 48 plus 24I, and in the other one when I multiply by a negative I by the current, okay, I would get 12 minus 24I. Actually, I times I is I square, and I square would be changed into negative 1. So don't get upset if you are writing the direct answer. If you are doing manually, then convert the I square into negative 1, and then you will get the same answer. So remember, in a circuit, if any of the any resistor or capacitor or inductor is not there, so in order to find the voltage, just write that part and write that there is no inductor or capacitor or resistor, whatever.